So I'm Josh, CEO and one of the co-founders over at Databand. I've been working in the data ecosystem really since I started my fledgling career back in the day. Floated around to a lot of different kinds of data teams, starting off in finance area, moving into product management at a big data company, and leading up to starting Databand, really to help data engineers, folks in this ecosystem, get better reliability out of the data that they work with. Fun fact on me, I'm a former chinchilla parent. That means I used to have a pet chinchilla, not a coat. If you're ever thinking about adopting one, call me and I'll talk you out of it. Now, what I'm going to cover today, I'm going to talk a bit about data observability and our unique perspective on this area at Databand. For anyone that is not super familiar with this category or this area, data observability, basically what it refers to is comprehensive monitoring and awareness of the data that you work with or deliver as a data engineer or analytics engineer. Observability, we think of as a pretty wide-ranging objective, really, a goal that fits into it a number of different kinds of actual activities to get a better handle on how your data processes are running. And that includes things like lineage, data quality, rule enforcement, different features that help you understand where problems are coming up. I think a big and burgeoning category of technology now, because there's been so much evolution and adoption of data pipelining and data product development. The market has moved from the position of how do we build data products and how do we get data from point A to point B towards we have data products, how do we make sure that these are working right before we ship them out to customers and have people actually making big, important decisions on the dashboards or analytics or machine learning models that we create. So on data observability as a category in general, we have a particular way of looking at this at Databand that I think resonates with a good chunk of the market, which is really thinking about this from a proactive stance, where the key objective is spending more time fixing problems and developing new kinds of analytics or models or data engineering processes, rather than spending all your time locating where those problems started. So really shifting that positioning and posture more towards fixing and new creative activities as opposed to a lack of awareness or trying to decipher where some issue might have occurred if it's detected somewhere or raised by an analyst downstream or a data scientist. There's a few different cycles that we see overall when we think about this as a life cycle in development. As an analytics engineer or a data engineer, first there's the detection of the actual issue. For example, schema changing from a source and that potentially breaking some process downstream. There's the awareness side of it, which is actually being able to go to the right stakeholders and describe to them what the impact of some change is going to be or some issue that was detected. And then there's the ability to iterate quickly and adapt to that change or get in front of the issue so that it doesn't actually create a big challenge for the folks that are working with this data asset. So when we talk about proactive observability, what does that actually mean? Well, what we're talking about is trying to catch problems to the left of the warehouse, meaning how do we catch problems or start really finding those issues even before they're in our analytical layer or before they're in the tools that people are really depending on in order to do their analytical work or the dashboards that may be the end of this stream or process. So within our company, what we really like to try to understand is how is data changing as early as possible? Where are those inconsistencies or breaks in data quality from source locations? And how does that flow through a lake or staging environment or directly into the warehouse that folks are using downstream to drive their analytical work? And how do we detect things like delays of data, missing data, anomalies when it comes to volume, or changes when it comes to the structure of these different data sets or data sources that you're working with, and issues that may relate to internals of the data sets or different data assets that you're pulling into your system. So we really want to try to, when we're working with teams, we want to help people understand as early on in the process where problems are happening and catch those in as close to real time as possible so that we can draw attention to their proactively very quickly. We look at observability as a broader hierarchy. We see this as having different levels to it. So as a data team, when you're thinking about the different levels of driving a data platform from the service level down to the actual data sets or data tables that people are working with, what are the different levels that you may want to consider when evaluating or building out or just thinking about observability and data quality? Well, how we look at it is on a few different tiers here that go from the higher level down to the more specifics. At the base of the pyramid, what we see as really important is understanding the operational health of your overall system and whether data is coming through at all, because we see a lot of challenges being surfaced because there's some failure or gap in the data itself, even before we're talking about real data quality issues. If you don't have any data at all, is that really a data quality issue, or is there something deeper happening in the service that might be blocking you from making use of that asset? So what we think about on the baseline of the pyramid is this operational health monitoring aspect, which answers questions like, did your data sets arrive? Or is it in the expected format when it comes in? The next level up on the pyramid that we consider is, once we know that the data's in within the system and everything seems to be flowing as expected, what's actually happening within the data sets that we're pulling from? So let's say we're an analytics team, we're doing marketing analytics, and we're pulling from LinkedIn ads, Facebook ads, Google ads. We crossed the first level of the pyramid. We know that these data sets are flowing in as expected through the API, through Fivetran, whatever tools we're using for integration. Next level up is, do we actually know what's happening within these data sets that might indicate some problem closer to the quality level? So examples would be, what's the completeness of individual columns? Is the data distribution that we see consistent and predictable? If we're expecting a pretty even distribution of impressions from LinkedIn and Facebook and maybe Google ads, is there suddenly a huge jump in one of those marketing channels that might indicate really a problem with the data, if not a meaningful event in the business that we need to know about, hopefully as early as possible? So column level profiling, this to us is understanding a little deeper level into the actual data. Then we go to the row. Once we understand the columns, we go into the row. And we want to help teams understand, does the data coming in from these different sources as it goes through different analytical systems, do the records that people are processing there, do those conform with the rules or the expectations that you have within the business? The last level down, the most granular level of enforcing or understanding expectations or rules at that fine-grained level of the actual transaction, something that sits within the tables. We sort of go from the data set itself to the individual columns, to the rows of the data set, each level providing more visibility. So that's a bit on how we view the pathway to good observability with our approach. Really excited to see if there's any thoughts or questions from the forum. I know that this is a group of hardcore DBT users, so it'd be really interesting to hear some of the ways what I've covered resonates with the audience, or some other ways that folks have thought about addressing these kinds of issues.
Thank you, Josh. Yeah, we'd love to get any thoughts or questions around this, experiences that you might have had with data observability. Go ahead and use the chat box for that. And of course, we're happy to answer additional questions even after we close up today and continue the conversation in Slack.
When you set observability thresholds for different levels of the hierarchy, are there industry standards that you use? I think that's also an interesting question. So with a solution like ours, we're providing an application that is cross-domain. We work with customers in the gaming industry, we have customers in media, we have customers in finance, a lot of different kinds of user profiles. And essentially, we push our product to the boundary of where we can apply generic best practice rules or heuristics that we expect to live across these different domains and pretty consistent across data teams. That's one level within our application. We know fairly well that whatever domain you're working in, schemas that constantly change will generally be a bad thing. You know, columns being dropped, type changes, structural issues to the data set. The areas that sit at that bottom of the pyramid, missing data, these are things that generally are not good, are going to be bad things, whether you're a finance institution or whether you're a hospital. Those are the kinds of checks or heuristics that we can enforce within our system to always say, these are the kinds of issues that always need to be alerted to the team about. When you go to the higher levels of the pyramid is where you need really to start incorporating more fuzzy, probabilistic techniques, or lean more on the user to help enforce what's okay and what's not okay. An example would be SLAs, which that can mean a couple different things in our world. There's the SLA that's often talked about from the data engineering side, which has a concrete meaning of a pipeline running too late or data not being delivered on time. And then there's a broader SLA, which is an actual service agreement that you have around your data. If we're talking about data not being delivered on time, that would be a good example of where rules that live across industries may not be really adequate, and where you want to lean more on techniques like machine learning to develop some baseline model that says, here's what's normal for when data gets delivered to this location. And we see that there's a unusual delivery today. Same thing goes for column level profiling. You have some domains where you can expect a lot of very skewed information and data sets. So you may not want to come in with a solution. If there's a lot of skew, we're going to kill a pipeline or we're going to flag a alert and inundate your team. You want something that's going to learn a little more with you as you push more data into the observability tool, and it creates a better baseline for you. So the higher you go up in this pyramid, the more you're going to need to lean on solutions that provide good machine learning and probabilistic modeling of how a data set looks, and rules or different criteria that the user is going to set up themselves. I hope that answers the question. And then the top question is a recommendation for most people to use DBT test for column level data quality. The DBT data quality toolkit, which I'd love to hear more thoughts on from the DBT folks in the room. As we see it, this would be a good tool set to leverage on issues that may be occurring really within the warehouse, like post-transformation, or issues that are deep within the analytical layer that are really coupled to how your DBT models or those jobs are running, those queries are running. We focus our attention from the Databand side as well as looking at how data is flowing into this system from the get-go. So that might even be before your DBT models really start kicking off. So we'd want to see, like, from the connector, from the integration points, from the staging area into the warehouse, this garbage coming in to begin with, and being able to rule that out and say the data is clean really from the get-go, and then looking at the transformation layer and metadata we can pick up there to provide deeper kinds of information or alarm raising.
Thank you, Josh. That was awesome.